Have you ever seen a balloon inflate all by itself, without anyone blowing air into it? Imagine that balloon sitting on top of a bottle like a little magic trick. This magic is powered by tiny creatures called yeast. Yeast are microscopic fungi, so small you can't see them, but they have an extraordinary ability. When you put yeast in a little bit of warm water with sugar, something remarkable happens. Let's say we have a bottle. Inside, we mix some warm water and sugar, and then add the yeast. Immediately, these tiny organisms start feasting on the sugar like it's a banquet. As they munch away, they produce a gas called carbon dioxide. This gas is invisible, but it's powerful enough to make things move. The carbon dioxide produced by the yeast gets trapped inside the bottle. With nowhere to escape, it pushes against the sides of the bottle and moves into the balloon. This pressure causes the balloon to inflate, and suddenly, without anyone lifting a finger, we have a puffed-up balloon. This little experiment might look simple, but if you start changing things around, it teaches us about something called biological reactions. For example, temperature plays a big role. If the water is too cold, the yeast will feel lazy, and the balloon might not inflate very much. If the water is too hot, it's like trying to nap in a burning hot room. The yeast can't take it and might not work at all. Then there's sugar. You might have white sugar at home, but what about brown sugar? Brown sugar has extra minerals, and these can change the way the yeast performs, kind of like adding new instruments to a song. By experimenting with different temperatures and types of sugar, we can learn what conditions make the yeast happiest and most productive. This sort of understanding isn't just fun, it's crucial for science. It's how bakers perfect their bread in the oven, and how scientists work on big projects like bioengineering. Isn't it incredible how yeast, these tiny, invisible creatures, can cause a balloon to inflate? It seems so magical, but it's really a clever use of nature's chemistry at work. By trying to vary the temperature or type of sugar, we make exciting discoveries about how living systems turn chemistry into visible work. So next time you see a balloon, remember that even the tiniest creatures like yeast have the power to make big changes, and with the right conditions, they can teach us so much about the world. Who would have thought such little things could create such a dramatic display?